the transport forms of what? Carbon dioxide. I'm waiting for the answers, please. What are the various forms we can transport carbon dioxide? At least you should know one from what we've discussed so far. Now, first, we'll talk about what? Dissolved form. Carbon dioxide is transported first in what? Dissolved form. What's the second form?
Hemoglobin.
What's the second form?
With hemoglobin.
With what? Hemoglobin. And what do we call that?
Carboxyhemoglobin.
Hmm?
Carboxyhemoglobin.
Carbamino globin. You can see carboxyhemoglobin, carbamino hemoglobin. Now, what's the third form in which carbon dioxide is transported? By what? Bicarbonate. You know bicarbonate, right? Bicarbonate. Bicarbonate. Now, we know already that what? Partial pressure of what? Carbon dioxide, we keep it in what? A dissolved form. Are we getting it? We know already that carbon dioxide will be kept in a dissolved form due to its what? Partial pressure. And the percentage of carbon dioxide that will be kept in a dissolved form due to its partial pressure is what? 10%. Please remember this very well, it's very important. 10%. Now, carbamino hemoglobin or carbon dioxide attached to hemoglobin, the percentage that you find that in what 100 milliliter of blood is what? 30%. And bicarbonate, we have the what? Highest. We give the reason why bicarbonate is highest as we go further. Bicarbonate will transport about what? 60%. Very good. Very good. Now, partial pressure keeps this one, CO2, in what? Dissolved form. Partial pressure. Partial pressure keeps it in what? In a dissolved form. Now, carbamino hemoglobin. What happens? How is this attached to what? Hemoglobin. And how do we transport what? Bicarbonate. And how is carbon dioxide transported by what? Bicarbonate. We are going to talk about that as we continue. Now, let's take bicarbonate. Now, this is our what? Our red blood cell. It has a biconcave shape. This is our red blood cell. And this is our blood, for example. And we know that in the blood we have what? Water. Right? Yes. Now, when you do a lot of, let's say there's high metabolic rate in the body, what happens? You release what? CO2. Right? Now, these are our tissues. You release CO2 from the tissues. As CO2 enters into the what? Blood, what happens? It binds with what? Water. Now let me enlarge it on this side of the body. Let's enlarge it. CO2 plus H2O will give us what?
HCO3. HCO3.
Carbonic acid. We have what?
2CO3.
H2CO3. We have what? Carbonic acid. Do you get that? Good. Now, carbonic acid will be broken down by an enzyme called what? Carbonic anhydrase. Into what? Bicarbonate. Plus what?
Hydrogen.
Hydrogen. Are we getting it?
Where does that take place from?
Is that?
Yes. Where does it take place from? They break it down.
They break it down. All this happens in the what? Blood, particularly in the red blood cell.
Sorry. And what enzyme? Carbonic?
anhydrase, carbonic anhydrase.
It's equal endothelial system.
Carbonic anhydrase.
From
It's in the red blood cell. Yeah. Carbonic anhydrase.
so the carbonic anhydrase that breaks down
The carbonic acid. This is carbonic acid.
into
Carbonic acid into bicarbonate. And what? A proton called hydrogen. Proton. Do you get it? Breaks from bicarbonate into bicarbonate and what? Hydrogen. Now this hydrogen will what? Move to what? Remember we said that's during what? High metabolic activity, right? Now, this is what? Our what? Hemoglobin in what? Red blood cell. And we know already oxygen binds to what? The ion in the hemoglobin. So now, and of course blood is at the pH of what? 7.4. Now, about 7.4. I know hydrogen, when you add more hydrogen to anything, you increase what?
Acidity.
pH or acidity. Do you get the point? So now, hydrogen, this hydrogen will now start what? Binding with what? Hemoglobin. As hydrogen start binding with hemoglobin, it what? Start causing what? The deloading of what? Oxygen from hemoglobin monomer. Are we getting it? Do you get the point very well? Now, let me take it again. We've broken it down into bicarbonate and what? Hydrogen. Now, hydrogen will start binding to what? Hemoglobin. And as start binding to hemoglobin, lead to what? Deloading of what? Oxygen from hemoglobin. And that oxygen will go back to the what? Tissues. But as we continue having this process going on in the blood vessel, what happens? The blood becomes more acidic. Are we getting it? It increases the pH. Are we getting the point very well? Get the point very well. But that is where the buffer system of what? Hemoglobin comes into what? Play. We won't go into that very well. Now, bicarbonate that was what? Also what? Produced due to that breaking down by carbonic anhydrase. What will happen? It will be exchanged with what? Chlorine. So bicarbonate will what? Go out. Chlorine will what? Come in. Are we getting the point very well?
So what's the use of chlorine?
Chlorine to increase the electronegativity in the cell.
To increase
Electronegativity in the cell. Do you get the point very well? To increase the electron, of course, chlorine negative increase the electronegativity of the cell. To like a balancing mechanism. Do you understand? Well, if you are bringing more hydrogen, the cell will be more positive. So you have to bring a little bit of what? A negative charge as you are pulling bicarbonate out. And bicarbonate will now be transported in blood. And of course, in bicarbonate, you have the original what? CO2. You will get that point very well clear. So that is how we get what? Transport of CO2 by bicarbonate. Is it clear?
Yes.
Is it clear?
Yeah.
Is it clear? Doctor, is it clear? Good. Now, the second form we said is what? Carb amino what? Hemoglobin. When CO2 binds with what? Hemoglobin. Particularly to the what? Amine part. NH2 part. You know hemoglobin, globin is what? Protein. And anytime you have protein, you have what? Amino acids, right? And globin is made up of a lot of what? Amino acids. Okay, let me ask a simple question now. What structure of protein do globin fall into? Is it the primary structure, the secondary structure, the tertiary structure, or what? Or the quaternary structure? Globin is tertiary structure. Tertiary structure. But hemoglobin totally is what? The quaternary structure of protein. Do you get the point? But globin itself, tertiary. Fibrous and globin. Very good. Now, so anytime you have amino acid, you know they will have an amine functional group. You get the point? Anytime you have amino acid, let's say what are the amino acids you know? Glycine, lysine, isoleucine, and the rest. They must have what? One side being an amine functional group, and another side being what? Carboxylic functional group. So, but the CO2 will bind to what? The amine functional group. That's what we call carboaminohemoglobin. Do you get the point? Do you get the point? That's where the name came from. Do you get my point? You didn't get it? Alright. I don't know. Alright. Now, let me take it more calmly. Now, CO2 will bind to the amino end of what globin? Amino end of the hemoglobin molecule.
Yeah, this is the protein.
Which is the protein part. Right? As it binds to the amino end, it will be transported with hemoglobin back to the what? Lungs. You got the point? So, this CO2 that binds to amino end of the hemoglobin is given the name, or this transport form is given the name carboaminohemoglobin. Is it clear? Carboaminohemoglobin. So that is how CO2 is transported by what? Hemoglobin. You get the point very well. Very good, very good, very good. Now, the third form is what? The dissolved form. Of course, we know that dissolved form is due to what? Partial pressure. So anytime we have oxygen carried in dissolved form, we say partial pressure. Carboaminohemoglobin, we know is what? CO2 binding to what? The amino part of the what? Hemoglobin molecule. Anytime we have what? The third form, bicarbonate, we know is due to what? The enzyme carbonic anhydrase that breaks carbonic acid into what? Bicarbonate and what? Hydrogen molecule. You get the point very well? Very good. Now, so these are the three different transport forms of what? Carbon dioxide. Very good. Of course, there are so many factors that determine this, but we won't go into that since the question didn't say that. When we talk about, when we are going to full lectures, we'll talk about that. But there are so many factors that determine all these things we've been talking about. You understand? pH is their temperature, their concentration. Alright, now let's go to the next question. Oxygen hemoglobin dissolution curve. Oxygen hemoglobin dissolution curve. Okay. As people will say, oxygen hemoglobin dissolution curve. Do we need a break or we should continue? We need a break? We need a break? We need a break?
No.
No. Do we need a break?
No.
It's 5 minutes, 5 minutes.
3 minutes break.
3 minutes break? Are you tired? You're tired? You're sleepy?
Let's go for frequency.
Are you serious?
No frequency.